Our first step is to identify our target. In our testing lab, we're using a virtual machine called Metasploitable. This machine is intentionally vulnerable, making it perfect for learning and testing. To find the vulnerabilities, we'll use a network scanning tool called ZenMap. Open ZenMap, enter the target IP address, and select the scan type Intense Scan. This type of scan provides detailed information about all the services running on the target machine. Once the scan is complete, look at the results. Among the various services, there's one that stands out. An FTP service running FTP version 2.3.4 on port 21. This version of FTP is known to have a serious backdoor vulnerability. At this point, we'll head over to the web and search for FTP D2.3.4 exploit. A quick search confirms our suspicion. The vulnerability is well documented on Rapid7's own website, and it's available in Metasploit. Now it's time to fire up Metasploit. Launch the framework by typing msconsole in your terminal. Once Metasploit loads, we're ready to search for the exploit we need. Metasploit has a treasure trove of pre-built exploits. We'll use the one specifically for FTP version 2.3.4. The command to select this exploit is use exploit Unix FTP FTP _234 backdoor. Notice how the prompt changes when we select this exploit. It now indicates we're working within this specific module. Next, we need to configure some options for the exploit. To see what needs to be set, type Show Options. Two critical settings need our attention. Our host, which stands for the remote host or the target IP address, and our port, which represents the target port. The default R port is already set to 21, so we only need to set our host to the IP address of our target machine. We do this by typing set R host your target IP. Once everything is configured, double-check the settings by running Show Options again. Now comes the exciting part: executing the exploit. Type exploit and hit enter. If everything goes as planned, you'll see a shell prompt appear. This indicates that we've successfully gained access to the target system. To confirm, type ID in the shell. The response shows we're now operating with root privileges. This means we have full control over the system. Now that we've gained access to the target system, let's take a moment to explore and understand what this level of control really means. As an ethical hacker, once you're inside the system, your first step is to verify the environment. Let's run the command uname. This gives us details about the operating system, kernel version, and architecture. Why is this important? Because it helps us understand the type of system we're dealing with, and whether additional vulnerabilities might exist. Next, let's use the ls command to list the files in the current directory. This gives us a sense of the target's file structure. It could reveal sensitive information, misconfigurations, or even passwords stored in plain text. But remember, every move you make must be intentional and well documented. Now, let's dig deeper by navigating through the directories using cd. For instance, if there's a directory named var www, this might host a website. Exploring it could reveal configuration files or potential vulnerabilities in the web application. We must demonstrate the full scope of the risk. To do this, you can try creating or modifying files to showcase the potential damage an attacker could inflict. Once we've gathered enough evidence, it's time to wrap up responsibly. Exit the shell by typing exit.